Anyway, we have only two participants today, but we shall continue with our journey. Now, the question is when you want to compare individual with a group, I repeat, when you want to compare individual with a group, at that time, you are going to use standard deviation. Let me keep a larger size. Can you see this? I hope you can. Now, we are talking about today a non-parametric test, a little bit difficult, but frequently we need to use it in case of small sample size. Now, we repeat that if we want to compare individual with a population, whether this person belongs to the population or not, at that time, which test is to be utilized? We'll say Z, but five types of Z out of that, which kind of Z? So I will give an example. Let's suppose there are 80 individuals staying in a flat. Out of this 80 individuals staying in a flat, the mean number of sickness days in a year out of this 80 is, let's say, 42 days. And the standard deviation is 10 days. I repeat, out of 80 persons staying in a flat, the mean duration of sickness during the year is 42 days and standard deviation is 10 days. Now, there is a person having age of 60 years and he stays sick for 70 days in a year. Then do you think that person is significantly passing more days in a sickness compared to others? Write down in chat box whether answer is yes or no. I will also write the question chat box. 80% staying in flats or there is a flat complex and mean duration of sickness days per year is 42 per year. With standard deviation is equal to 10 days. The question is the 60 years old male is passing 60 days, no, 70 days in a year. Is this significant? Type your answer yes or no. Or if you can't, if you do not know, write do not know, but write something. Today, you will, if you participate, you will be almost expert which test to be utilized when. What is your answer? Or can you write a formula for Z? Dr. Nidhi, Meenakshi, Dr. Saranya, or you can say do not know. Let me give this. You need to use this formula. Z is equal to population mean my observation divided by standard deviation. So in this case, what is the answer? No answer? Write down something. Yes, let us try to use this formula. In this case, Z is equal to population mean VSA is a you can take as an absolute value 42 minus the observation 70. We need to take a of absolute value divided by standard deviation is 10. So the answer is 28 divided by 10, that is 2.8. So Z is more than 2. So probability that this person is spending 70 days in a year by chance is less than 0.05, means the 1 up to 20, so that mostly the staying sick for 70 days is seems to be having a significant, there has to be some significant reason behind that. So we'll say that the it is a significantly more than the rest of the population staying in the flats. So is this clear? Then we'll go to the other examples. Okay. Now the next example for you to calculate, we are talking about, let's say, same population. In that, the flat, what we are talking about, the sickness at a given point of time, let's say in month of July, let's say in month of July, here only will write the question. Here we are asking that out of 80% in month of July, let's say 20%, uh, let's give a June so that it is more appealing, and 20% had suffered from one or other illness out of 80. Out of 80. Now, the question is, if this flat was in a town, and in town the total population was let's say, a small town is a 20,000. And considering that this 20,000 population was represented by this 80%, suppose that is the presumption, what will be the percentage of sickness in this 20,000 population? Suppose this 80% are representative of this 20,000 population. Then what is your figure that how many people would have suffered in month of June out of 20,000 population? If you know, tell me the answer. So let us calculate together. See, if this sample was belonging to the population, then population proportion belongs to sample proportion plus minus 2 standard error. This is the question, the thing. So you need to find out the standard error in this case. And standard error, you know that is equal to, here you can see, standard is equal to the square root of PQ upon N. Square root of PQ upon N. So here we can find out that standard error proportion is equal to root, right? Square root of PQ upon N. Here P is 20% had suffered out of 80. So 25% is suffered. So 25 multiplied by 75 divided by N is 80. So this answer we need to find out, and that will be the standard error. Based on standard error, we can find out what will be the number of people suffering in the population. So you can also try to calculate this figure. It will be roughly 4.8. So standard error is equal to 4.8. It means that the population proportion would be between population proportion is equal to sample is 25% because 20 out of 80 plus minus 4.8 to 2. So 9.6 is almost 10. So we can say that in a population it will be between 15 to 35%. That means 15% of 20,000 population would be, if you take a 10%, it is 20,000, so 3,000 to 35% will be almost equal to 7,000. Person would be sick according to the data, according to this data. So this is the answer. If you have understood or not, you should write something. All of you should write something in the chat. Then only we can go ahead. Either you understood or not understood. Again, some question can be asked to you. What about others? What about others? So if you have understood, my another question is, suppose the actual survey when done in this 20,000 population, data was taken out, and it was found that actual number of people who suffered was 2,500. 2,500 out of 20,000. So in this case, you are a chief medical officer of the town, and your opinion is taken whether the person who are becoming sick in the flat have a significant different cause of becoming more, or they are the same at the same level of the sickness with the rest of the town. So what is your answer? 2,500 is almost same or different? Write down the answer. I think you can unmute yourself and then also speak because this is a discussion forum now. Okay, we have learned enough, but now application is necessary to for the discussion. Then we'll go for the another example. And then today we are going to take about non-parametric test also. The question is, actual survey showed that 2,500 people were sick in month of June out of 20,000. So is this significantly different from the flat or not? The flat people were more sick or less sick compared to this general population. What is your answer, Nidhi? Meenakshi? Anyone? You need to spell out something. Like the it won't be same. It would not be the same like flat people. So what is the flat people are suffering more or same? Is there a significant difference or not? How do you calculate that? So calculation should be like this. In this case, Z is equal to population proportion minus sample proportion divided by standard error proportion. In this case, standard error proportion, we know that it is 4.8. So answer will be like this. Z is equal to, see the population proportion, it is in this case 2,500 out of 20,000. That means 1250 out of 10,000. So 12.5% minus sample is 25% divided by 4.8. That is definitely more than 2. So we can say the P is less than 0.05. And you can say that difference is significant. So you can answer that there's a significant difference between the prevalence in the flat versus in the town. So in flat, there is something which makes people more sick. You need to find out the mosquito breeding, or need to find out some polluted place, or they might have something shock, that kind of thing. So this is the question. Now we have another example in this case. We take now, we need to have a comparison between the population sample, same example in the flat people, right? The sickness in this case, we'll say the duration of sickness in the flat per year. So, flat people, mean duration is 42 days and standard deviation 10 days. And in this population of 20,000, the mean duration is 36, 36 days. Now, tell me whether the flat, the people, the sickness days per year is as good as the general population or it is more than that. You need to calculate this. and tell me the answer. So in this, you need to find out Z is equal to population mean minus sample mean divided by standard error of mean. Standard error of mean. This you need to find out. And then find out whether it is more than or less than. So if you are not in pen, you can do it. Else we'll keep it doing it over here. Z is equal to, because we need to find out standard error of mean. So square root of SD by N, right? So in this case, let us find out answer. The square root of oh, SD is 10. So square is 100 divided by N is 80, right? Because in flat, 80% are staying, 80% staying in, in flat. So answer would be S is equal to square root of square of standard deviation, that is 10 days is a standard deviation. So 100 divided by the population N with 80 is equal to, we can say that 100 by 80, 10 by 8 will be um, 1.25. Square root of 1.25. So approximately you can say that it is 1.1 will be the answers, standard error. Now in this case, if you want to find out Z, that means Z equals to, here the population mean is 36 days. 36 days minus the population is 42 days divided by the standard error of mean. So answer will be 6 divided by 1.1, something like 5 would be around 5.5 or so, means it is more than 2. So you can say that the mean duration of illness among the flat residents is much more than the population mean duration. So this is your answer. And if they ask you to find out based on the flat dwellers, what will be the population mean? If it is a really representative, then your answer should be population mean will be is equal to sample mean plus minus 12. Sample mean is 42 days plus minus 2 standard 2 into 1.1. So roughly it will be between 40 to 44. 40 days to 44 if it is a representative of the town. So mean duration also you can calculate like this. I pause for 2, 3 minutes. If there's a problem, you come out. See, this is standard of mean and standard of proportion has a two types of application. It finding out the difference between population and sample mean means whether this is a representative or not. And another thing is if it is representative, you can forecast the population mean based on sample mean. If you want to find out the whole population mean based on sample, you can find out provided sample is taken representative. These are the three that we talk about. Another two we'll talk, and then we'll be going for the non-parametric test. Any questions so far? So now, when it comes to comparison between two population, here we'll not spend the time for the calculation, but we'll give an examples. So here we had taken example of Nagpur and Ahmedabad. Similarly, if you have two population or two sample to compare, at that time you use the formula standard error of standard of proportion, standard of difference between two proportion that you will be using. And suppose you want to compare in the same example number of people sick in flat versus number of people sick in a society like this when you are comparing two things together. Similarly, duration of sickness in flat, duration of sickness in society. This, when you want to compare, you use the standard difference between two mean. But then, instead of two, if you have three or more things to compare, 4 cities, 5 cities you need to compare, then you will be using chi-square test in case of proportion. But when you have more cities to compare, 3 or 4 cities to compare, for example, the uh, mean duration of illness in the citizens of Ahmedabad, Baroda, Nagpur, Pune, like this. At that time, standard of mean will not be useful, and you need to go for the test of variance. So now we'll be going for a small data. This F test you can use provided you have data which is large data you have. But when you have a very small data, I will take an example. You only, let's say, four types of cities, not cities, I would say four type of clinics, and you want to find out mean reduction in blood sugar. And each clinic have, let's say, 4 to 5 patients only of diabetes. Then if there is only 4 patients or 5 patients in each clinic, and if you want to compare, your F test is not going to work. So what do you do in these cases? You have, let's say, 4, 5, 6 series of such data, different cities, different ward, different sect, different data, and you have very small numbers to compare. So if you have some idea, you can write in chat box. Do you have some idea how we analyze such data, small data? So in this case, we are going to use non-parametric test. And this non-parametric test, now we are going to use it. We attend carefully so that you can understand it well. And in life situation, we may face such situation, very small data size are there. So let's go for that. This test is known as Kruskal-Wallis Hatch test. Let name be bigger, but then it is very simple to understand. When we have more than two population, three, four, five groups, and there's a random design, and we want to find out whether there's a significant difference or not, at that time, we'll be utilizing this Kruskal-Wallis test. And all the measurements in each group, we think that as if it's a one series, and then we give them rank, first, second, third, fourth, like that. That we'll see how it is to be done. And all the sums will be there for each rank. You do not make a total of the observation as it is, but you will be make a total of the ranks. We'll see in the next slide. So it makes easier for you to understand. So the formula looks very difficult, but it's very simple. And we have K samples. K means if you have four, you can say four samples. Five, you can say five samples. And in each sample, suppose you have a four observations, 16 observations, then your N is 60, like that, right? And in each group, let's say the first group, second group, third group, fourth group, then that we find out that how many rank you have done out of how many people, four people, five people, like that. So this difficult looking formula will become simple soon. This N is total number of observation in all the samples. In our case, this is 16. We'll write N is 16. This T is basically the number of the groups, how many number of the groups. From each group, we'll make a total and divide by the total number in that group. Now see how we actually do it. In this case, when we talk about null hypothesis, we say at zero. Means there is no significant difference among the groups. Let's say we are four groups. In all the four groups, there is no significant difference. And H1 is at least there is a distribution is different in one group. Out of four, let's say three are normally distributed. But if one is not, is a different, then also we'll be able to find out. Just like chi-square, we are using the word Kruskal-Wallis H, right? And the degree of freedom in case of the chi-square, we are keeping column minus 1 multiplied by row minus 1, and that degree of freedom we are keeping. While in this case, how many samples you are having? That number of samples minus 1 is the degree of freedom in case of H test. Now, when we use the word degree of freedom, in chi-square, this is the column 1, column 2, column 3, and R1, R2, R3. And when you keep some figure over here, let's say 10, 30, 60, where 8, 4, 2, 1, and 2. In this case, what happens degree of freedom means if you have only this much data, suppose this is your data, then you can have total like this. and you will have total here also. In this case, there are four cells are there. How much degree you have? How many cells you can change? What is the freedom? So your freedom is you can change only this figure. The moment you change this figure, automatically rest of the three figures you cannot change. Let's say in this example, instead of 10, if you keep it 11, then to keep it 23 over here, you need to keep 12 over here. And here you need to keep 11. And automatically you need to keep. So once you change this figure you cannot change. It has to be fixed. Only one thing you can change. Rest of the thing will be depending on this. That means number of 2 are there, then minus 1 is equal to 1. Here also 2 minus 1 is equal to 1. So in this case, 2 minus 1 multiplied by 2 minus 1. So degree of freedom is equal to 1. In this case, there are 3 columns and 3 rows. That means these 4 figures you can change. Automatically, once you change these 2 figures, this is fixed. This you cannot change. It has to be dependent on this. Similarly, this also, if you change this 2, you can do it, but this you cannot change to make a total. So last one you cannot change, but rest of the thing you can change. So we say that degree of freedom is equal to 3 minus 1 into 3 minus 1. So it's equal to 4. So degree of freedom 4 here, degree of freedom 1 over here. And that degree of freedom in our case of Kruskal-Wallis is number of groups minus 1. Any question? You can stop me anytime. Now, in this Kruskal-Wallis test, let's say an example. Just try to concentrate on this example. We have 4 groups over here. Or you can say the 4 classes in class 1, 2, 3, 4. You have only 4 students who are studying in the other group. It's not necessary that you should have only 4 students in each group. There could be 5 students, 3 students, 4 students, 6 students like this. And now we want to compare in such a small data that is this significantly different or not. So if you try to apply a F test over here, it is not possible. And that's why we are going for Kruskal-Wallis test. It's very simple and very easy to understand. Right? These are the 4 groups. So total number of observation are 4 into 4, 16. Right? And we are now going to give a rank from smallest number to the largest number. The smallest number is 59, there's a 1. The next 662 is a 2. Next is 65 is 3. So we are giving from number 1 to 16 into bracket. I hope you have understood this. I think if you are keeping your video open, you are keeping your mic open, and then respond, then I will understand whether you have understood or not. Anyway, now once you have given the rank, the total is made over here. Total is not of the original values. Total is for the rank. And why we are doing like this? Because this number may vary a lot, 65, 94, like this. But when we give them a rank, the variation is much less. And you get the nearer the figure. So here is a 15, here is a 55, here is 35, 31. What does it mean? That here, these are the people relatively much less marked. These are the people who are getting relatively more marks. And these are the middle. But now, is this difference significant or not? How to calculate this? This is a simple number. First, T second, T third, T4. This is a four sample is that means T4 like this. That's why we are using the word T. Now, H0 means no significant difference. HA means there is some significant difference. Let us apply this formula. Now, the figure 12 is a constant. In each of the formula, 12 remains the same. But n is 16. So n plus 1 will be 17. Now, pi square, that means 31 square, 35 square, 15 square, 55. So these squares are there. Ni means number of samples. 1, 2, 3, 4. Total 4 samples. So we are dividing by 4. Minus this 3 into bracket n is equal to 16 plus 1, that is 17. So if you calculate, the answer is 8.96. It's just like a chi-square. Chi-square value is 10 or 15 or 7, something like that. And here you can see there are 4 samples. So degree of freedom is 4 minus 1 is 3. So this is the answer. And degree of freedom is equal to 3. So if you look at the chi-square test, you will see that the table value is 7.81. And here the calculated value is 8.96. So what do we do? Calculated value is more and the table value is less, 7.81. So we can easily say that the data distributed is not evenly distributed, not normally distributed. That means there is some difference somewhere. And so we reject the null hypothesis and the accept the alternative hypothesis. And that alternative hypothesis will say you that this four sample, they are doing much better compared to others. Or you can say the third sample is doing much less compared to the others, while number one and two are in between. So this is how we use the H test, crystal Wallace test. I think I have already shared this file with you. You go through that file today or tomorrow, then you will understand how to apply this test, right? Otherwise, if this data is given to you, you may not be able to answer that which one is better, which one is not better like that. So any question? So then we should be going for your projects. If you have written something, then you can present also. So now I think if you have presentation ready, you can present, you can ask the question or you can have a discussion. But then 5 types of Z, non-parametric test. We have taken the initially the kappa test also we have taken. We have also done the uh, based on the lots quality assessment. And today we have taken Bristol voice test. Next time we are going to do a main Whitney test, which is also non-parametric test. And if have something question answer, this is okay. Then we'll be doing a practice on AP info. Today we can go for some Excel file also. Any question? So you think of the question. Meanwhile, I'll be preparing one Excel file. Let me share the screen. You can share with the groups your topic at the same time so that it will be better. So we will be able to discuss next time. Discuss with the where whatever your topics are, it is better to share in the groups. And I will share the screen for the purpose of showing you an Excel file. Let's say you have an Excel file where you have something like this 45, 52. You have such data in Excel and you should be able to analyze the data in AP Info. Excel file that you're using in AP Info. And urban or rural. Suppose this is your Excel file. Keep the headers clear. Nothing, there no, should not be any merge, etc. And once this is over, we'll be using the analysis. Now, when you use this file, it is better if possible to save as a lower version to avoid any problem. XLS and give a name. So now you have a lower version ready for analysis. Now let's open the 15 book file. Classic, we are opening. In this case, the first step to read is read the Excel file, and that you can select from this XLS. Browse. You need to find out from your desktop for analysis. Sheet 1. Frequency. Star. Because we have selected sheet 1, this is the answer. Now, if you want to select another file, we need to have selected sheet number 3, right? So let us go to the read the file, XLS, browse for analysis. Okay. And set 3, where our data is. Now let's go for frequency. Start. So now this we are analyzing from the Excel file directly. ABCDFG like this. Then comes age group, pass or fail, marks, rural, urban, and this is what we are getting. Right? Now, if you want to use the tables command between urban and rural versus pass or fail, we'll get some percentage over here. This is how we are going to get a tables command. And then we go for the means command, mean of marks versus urban rural, that comparison. So we can say that the rural is 74 marks, urban is 77 marks. The standard deviation, everything comes over here. Same thing, we can go for age-wise. Means command, age versus urban rural. Rural age is 33, urban is 27 years. Whether this difference significant or not, p-value is zero point 0.3, so not significant. Similarly, you can compare between two. Outcome is a marks versus the age. And it measures, is there any regression coefficient? What is that? Whether it is a positive or negative, it is a negative. So as age increases, the mass is decreasing. So regression analysis can also be done. So in this case, Excel file, our purpose is how to use Excel file. So I think it is clear with you that in AP Info, you need to select which kind of file is to be utilized. So if you have some data in Excel format, the most important you just try to do that the first line, there is a column, the first row should be the header only. There is nothing like merge, etc. And this file, if you can use it directly into AP Info, it's very good. But by chance, if AP Info denies it, then you need to save as a lower version. So forum is open for question. Next time we'll be using man-Whitney test as a non-parametric test. And if you have already shared your file in the group, we'll be discussing that project. That will be the agenda for the next the session. All are invited to attend the evening session also. So any question? Meenakshi ji, Sudha ji, and the who are there, but they are not responding. You should at least write down whether you understood, not understood, 5%, 10% like that. So let us say the next time would be you should share your project proposal in group if possible. The main thing is sample size, how you have selected, and sampling technique. If you have any problem with the budget, you can talk to this. You can search for funding agency. So now let us stop here and we'll meet again on first day.